Okay, today we're going to keep talking about section 8.2. So yesterday we talked about sequences, which are lists of numbers. And today what we're going to focus on are series, which are, well, it's a list of numbers still, but it's when you're adding them up. So that's the only difference, is now we're going to be adding up a whole bunch of terms. So we're going to start with a little story. This is a picture of Carl Friedrich Gauss. And the story goes that when he was in elementary school age, like 7 to 10, he was a child prodigy. His teacher told the class to add up the numbers from 1 to 100. And the story goes that the teacher thought that this would buy some time, keep the kids busy for a while. But this little guy was able to add them up super fast because he saw a pattern. So I'm going to write out the list of numbers, but I'm going to hop in the middle. So I'm going to jump and I'm going to skip to the end of the list. So what Gauss figured out was that if you take the first number and the last number and you add them up, you get 101. Same goes if you add up the second number and the second to last number. 2 plus 99 is also 101. And then you keep going. 3 plus 98, that's also 101. 4 plus 97 is also 101. So how many 101s are there? There's going to be 50 of these. So what Gauss did was he took 50 times 101 and he got 5,050, and that was the correct answer. So he did it super fast. And this is the formula that we can use to describe exactly what Gauss did. So here's how the formula works. N is the number of terms that you are adding up. A sub 1 is your starting term. And A sub n is your ending term. So in this case, we had 100 numbers that we were adding up. So we were finding the sum of 100 numbers. So n would be 100. The starting term was a 1. And the ending term was 100. So if you simplify this down, we will have 50 times 101, and that's exactly how he did it, 5,050. Now just keep in mind, this only works for arithmetic series. So what makes something arithmetic? That's when you're adding the same number each time. So in this case, we're adding a 1 each time to get to the next number. So because this is arithmetic, we can use this formula, and this is when you want to find the sum of a list of numbers, so think S for sum. Okay, so we're going to be using this new formula as well as the formula from yesterday. Just as a reminder, the formula from yesterday looked like this. And this is the formula that we would use, again, for arithmetic, but this would give us any term we want. So it gives us a particular term. So this would be a good formula if I wanted to know what the 1,000,000th term was. I could plug in a 1,000,000 in for n. So we're going to use both of these formulas today. All right, here's another example. So I've got this list of numbers. I want to add them up. I could certainly put them in my calculator. No big deal. And that's because this list is relatively short. But what if I had 500 numbers? I personally would not want to put 500 numbers into my calculator. So as long as it's arithmetic, I can use this formula right here to add them up really quickly. So I have to verify that it's arithmetic first. So look at the list of numbers. Am I adding the same thing each time? So it looks like I'm adding 4 each time. So my common difference is a 4. Yes, it's arithmetic, so I can use this formula here. All right, so a sub 1 is my starting term. My starting term in this problem is a 2. A sub n is my ending term. In this problem, that's a 98. So here's what I have of my formula so far. What I need to know now is how many terms are there? What's going to go in for n here? So count up how many terms there are, and you'll see that there's 25 terms. So n is 25. So if I want to sum up 25 terms, I'll do 25 divided by 2, and then 2 plus 98 times 2 plus 98. So I'm going to get 1,250 for my answer. Okay, in this problem, we're supposed to find the 100th partial sum. So what that means is we are just going to add up the first 100 terms. So I could list out the first 100 terms and then put them all into my calculator. I don't feel like doing that though. So if I'm going to be adding up terms, I'm going to use, oh, I have it written down here, so I don't need to write it again. So I would be using this formula down here if I want to add up 100 terms. So here's the things I know right now. I know that there's 100 terms I want to add up. I know the starting term is a 4. The only thing I don't know yet is what my ending term is. That is my ending term, which would be the 100th term. It's not a 100, it's what number would go in the 100th spot if you were to list them all out. And again, I don't want to do that. So the faster way to figure out a specific term is to use the formula from yesterday. We have all of that information. So I know my starting term is a 4, and I know the common difference. What are you adding each time? Look at the pattern of numbers. The thing that I'm adding each time is 13. So here's my general formula. If I want a specific term, like if I want the 100th term, I just plug in a 100. So plug this in your calculator with plugging a 100 in for n. And you'll see that the 100th term is 1,291. So that is the number that would go in here. 1,291 is the 100th term. So now if I use this formula, I will be able to get the sum of the first 100 terms without having to actually list them out or type them all in my calculator. So type in this purple stuff into your calculator and you're going to get 64,750. So if we wrote out all 100, the first 100 terms, because this list goes on forever, so I'm just adding up the first 100 here. If I was to list them all out, put them all in my calculator, that's the sum. So it's a nice thing to know because it just makes things go faster. All right, we got one last problem. So here we've got an auditorium that has 40 rows of seats. I'm going to draw a little picture. So let's imagine that there's a stage here. The first row has 20 seats in it. The second row has 22 seats. The third row has 24 seats. So do you see how we're adding a seat on each end? Essentially, we're adding 2 seats into each row. So the next row would have 26 seats. So here's what I'm noticing, that my common difference is a 2. I'm adding 2 on each time. That might just be interesting to write down when you realize it. And this is just going to keep going until I have my 40th row. Now, I don't know how many seats are in the 40th row. So that's something that we could figure out. Now, if I'm going to use my summation formula and I'm trying to, well, if you read the question, it's asking how many seats are there in the entire auditorium. So I would want to use my summation formula for that to figure out the total number of seats in 40 rows. So I would do 40 divided by 2. I would need my first term. My starting term is 20. That's how many seats are in the starting row. What I don't know is how many seats are in the ending row. So this is very similar to the last problem. So I need to figure out how many seats there are in the 40th row. I can use my formula from yesterday to figure that out. So I know that my starting term is a 20 and that my common difference is a 2. And if I want to figure out how many seats are in this 40th row, I can just plug in a 40. And when you plug a 40 in, typing all that stuff into your calculator, the 40th term is going to have 98 seats. So the 40th row has 98 seats. Okay, but just remember, that's not the answer to the question. That's just how many seats there are in the 40th row. I'm supposed to figure out how many seats there are in the entire auditorium. So what we just figured out was the ending term. We now know that the ending term is a 98. So now I can find that sum, type all of this into my calculator, and I'm going to get 2,360. So that's how many seats there are in the entire auditorium. So sometimes you have to use both formulas. Just remember that, we'll just do like a little summary here. The formula from yesterday lets you find any specific term. But the formula from today, the formula with the S, that helps you figure out the sum. So S for sum. So it lets you add up all of the terms. All right, so that's pretty much it for today. We're just going to be now taking a sequence of numbers, a list of numbers, and we're going to be adding them up, and that's what a series is when you add them up. Okay, there's more to this section, but we'll finish it tomorrow. Have a good day.